Picking up where we left off, we're going to jump right into practice number 3. It says the results of a study on body temperatures of men and women are shown in the table. The data are from random samples from normally distributed populations. Okay, so in that table, you can see instead of describing all of these values in a sentence like we saw in the previous problem, here they're just giving it to us maybe a little bit easier in this table format. So we've got the men and the women. You notice that they're calling the men group number 1 and calling the women group number 2. They don't tell us the values of mu1 and mu2. Turns out we don't need those. Instead, they tell us x bar. So for the men, that would be x bar 1, 97.57. And for the women, which would be x bar 2, 97.46. They give us sigma 1 and sigma 2, and they give us the sample sizes of each N1 and N2. So you kind of look at those numbers, and I kind of like to ask the class, just on their personal experience with this. Personally, I find women tend to be colder on average than men. They like to wear their sweatshirts and things like that in the movie theater and that sort of thing. Just I don't just my own personal experience that women do have a lower body temperature than men. But let's see what the data says. Maybe that isn't founded on anything that is statistically significant. So we go down to the bottom using a 0.10 significance level. Test the claim that men have a different body temperature than women. And notice the way it's phrased. We're testing to see if men have a different body temperature than women. So that's going to influence our hypotheses, which is where we begin. So step number 1, state the null and alternative hypotheses. And we notice that these are 2 independent groups, right? The results for the men are independent of the results for the women. These are obviously different people. And so the outcome of one does not influence the outcome of the other. So here we go. The null hypothesis here for 2 independent groups, and I'll just tell you now, it's always going to be what you see. In every case for 2 independent groups, H0 is always mu1 minus mu2 equals 0. So what would it be for the alternative hypothesis? Well, we still have H1, mu1 minus mu2. We still have the 0. But what symbol goes between them? Well, and in this case, we got to go back and read the question carefully. And as we pointed out a moment ago, it says, test the claim that men have a different body temperature than women. So we're just going to fill in a not equals. What does that mean for the rest of this hypothesis test? And so I'll show you guys here. Whenever you have the not equals, that means you're doing a 2-tailed test. And so you have to split the value of alpha between the upper tail and the lower tail. So I've drawn this bell curve. You notice at the center we put 0 because we're thinking of the differences between the 2 means. The 0 goes there, and since alpha is 0.10, we're going to take half of that and put it at the upper tail, half of it and put it at the lower tail, so 0.05 in each. So if we make it into either shaded region, we know we have enough to reject the null hypothesis. Okay. From here, we'll go on to calculate the test statistic, and I'm just going to show you my results just like that. In this case, notice that we are given sigma, and so we're going to, this is like the original style with the z-score. So we can fill in x1 minus x2, x1 bar minus x2 bar, I should say. 97.57 minus 97.46 minus, and this piece here, it's always going to be 0 because we assume the difference is 0, or the difference is 0. divided by big square root, and then we've got sigma 1 squared over n1 plus sigma 2 squared over n2. Be careful when you calculate that. Be sure to use your parentheses and everything the way you should. When you round it, you'll end up with a z-score of 0.73. Okay. At this point, once we have the test statistic, these tests feel exactly the same way as the one sample test, right? With that, we find the p-value. So we'll use our normal calculator in StatCrunch. Our p-value equals the probability that capital Z something 0.73. Well, at this point now we need to decide, do we use a greater than or do we use a less than? And we can't go back to our we can't go back to our alternative hypothesis to figure that out. So what are we going to do? We're going to say, you know what, back up here, the first group was bigger than the second group, right? The men was this, the women was this. Group 1 was bigger than group 2. So since this was bigger, we're going to use a greater than. And then, of course, the other way to distinguish it, if you end up with a positive z-score, then you know use a greater than. And of course, the positive number came from the fact that this was bigger. Because that number was bigger than this, we end up with a positive number here. Okay, in any case, use a greater than in your StatCrunch calculator, and I'm going to round it to 4 decimal places, 0.2327. 4 decimal places is usually good. Sometimes there are many zeros, and you just have to go further than 4 because there's so many zeros. But if not, 4 decimal places is a good rule for the p-value. And okay, let's compare. Now, remember that we're comparing to alpha over 2, which is 0.05. So 0.2327, well, that's the bigger number. In fact, it would have been bigger than the original alpha as well. But don't compare it to alpha. Compare it to alpha over 2. Since the p-value is bigger, well, what can you say? We don't have enough evidence. You might argue there's some evidence, but certainly nothing conclusive. We fail to reject the null hypothesis here. And let me give you the statement on the interpretation. There is not enough evidence that men and women have different body temperatures, at least not according to this data. Okay. And you notice, that data, we had some big sample sizes, right? 45 men, 59 women. We did our due diligence for sure in collecting that data, whoever collected the data. All right, moving along. You notice next in the lecture document, we talk about the confidence interval for 2 independent groups. So this is good to mention. Let me just tell you what's going on with the confidence intervals and why they're coming back here. So the confidence intervals that we studied in Chapter 8 went along with the hypothesis test that we did in Chapter 9. Of course, there's a relationship there and even a relationship with the formulas. Well, there are confidence intervals for 2 independent groups as well when you do 2 samples. And so we need to mention those here. Just to let you know, you're going to see confidence intervals, in the homework. You'll be tested on them, all that. Also, when it comes to your final project, you might very well be doing, sampling and hypothesis test with 2 groups. 2 samples, so you'll be doing confidence intervals on your final project as well, and so you want to get some practice with that here. We just mentioned these briefly. We don't do a lot of examples. We just kind of are shown what they are, and then we see them. So here we go. What's going on with this confidence interval for two independent groups? It says, again, use the differences of measures to find the point estimate and the margin of error. And we've got the formulas. The point estimate, if you remember previously, the point estimate was simply x bar, but now the point estimate is x1 bar minus x2 bar. So we take the difference. And that's all there is to the point estimate. The margin of error, now this formula changes. Depending on if you have a z-score or a t-score, the margin of error is z square root sigma 1 squared over n1 plus sigma 2 squared over n2. If it's a z-score, if it's a t-score, excuse me, the margin of error has the t in front, and then instead of sigmas, you have s's. And you see the similarities between those formulas and the denominators in our test statistic. Okay, let's try one of these out. Oh, and then at the top of the next page, you see how to actually compute the confidence interval. You take your point estimate minus the margin of error, your point estimate plus the margin of error, same idea there. Okay, let's get to number 4. We're using the same data on the men's and women's body temperatures. Let's find the 95% confidence interval for the claim that men have a higher body temperature than women, round to 2 decimal places. Okay, how's this going to work using that same data? Well, let's begin with the point estimate. We need the point estimate and the margin of error, right? If the point estimate is x1 bar minus x2 bar, well, we're just going to fill in those numbers. So in this case, it would have been 97.57 minus 97.46, which is 0.11. Literally the difference between the two sample means, 0.11. Okay, to find the margin of error, well, we're going to use our formula. One thing, if you remember, we can fill in all of these numbers, but what do we fill in for z? And that comes from the fact that it's a 95% confidence interval. Let me try and keep that formula on the screen. Because it was a 95% confidence interval, you might remember that z will equal 1.96. Now, if you don't remember that, right offhand, you can use your normal calculator to work backwards the way we did it with confidence intervals previously in chapter 8. Okay, so for 95% confidence, our z is 1.96. So we're going to plug all that in to find our margin of error. 1.96, 0.84 squared over 45 plus 0.65 squared over 59, big square root, right? That's identical to the denominator in our test statistic. Multiply it by our 1.96, and you will get 0.30 if you round to 2 decimal places. Now that we have the point estimate and the margin of error, we can very quickly find the confidence interval. We'll take our point estimate and subtract the margin of error, and then our point estimate and add the margin of error, and we get these numbers right here, negative 0.19, comma 0.41. What we have found, that interval tells us we are 95% confident that the true difference between the average man's temperature and the average woman's temperature is somewhere between negative 0.19 and 0.41. Now, what is the negative all about? So remember, we're taking the difference and we're thinking still of the men as group 1 and the women as group 2. So when we subtract them, if it's negative, that means the women's body temperature was actually higher. If it's positive, that means the men's body temperature on average is higher. So you can see that we're not completely sure, right, that men really do have a higher body temperature than women. We're allowing some negative, we're allowing almost double that positive. So we have some evidence that men are a higher body temperature on average. but nothing conclusive. We're 95% confident that if we knew the average man and average woman's body temperature, when we take the difference, it's going to land somewhere in there. Okay, let's stop this video here. We're going to look at matched pairs next.